Hello, everyone. In last class, we discussed about clustering and two methods of clustering I have discussed. One is known as the hierarchical clustering, and another one I discussed about K-means clustering. Today, we are going to discuss about classification. So let me write in the document. So last class, we discussed about clustering. Today we are going to discuss about classification. Classification. Okay. So if I do a difference between them, if I discuss those things by writing side by side and their differences, then everybody will understand what is clustering and what is classification. So the difference between clustering and classifications will be as follows. The difference between clustering and classification are. So what are the difference between clustering and classifications? That is what I'm going to write now. So if I write here clustering, and then I put a partition in there, and then let me write it further like this, and I want to put here classification, then we can find the difference between them. Okay. So clustering means you are making clusters that are of similar types. If there are 3 clusters, so that means in the first cluster, the elements are of the same type. Second clusters, the elements are of the same type. Third clusters, the elements are of the same type. On the other hand, classifications, there are already 2-3 classes. For the new observations, that new observation should be put on the what classes, that is called the classifications. Okay. So for example, okay, so there are 2 methods for clustering, 2 methods that we discussed in the last class, 2 methods. So one is called hierarchical clustering, and another one is K-means clustering. K-means clustering. Okay. On the other hand, in the classifications, we will today discuss 2 methods. These are known as the KNN. Another one is naive Bayes. Okay, naive Bayes. So KNN means K nearest neighbor. NEIZHBOUR. K nearest neighbor. So KNN means. Okay. So this is the thing. Now let me draw the graph. If I draw the graph, then it will be very clear for you why clustering and classification are different thing, and it will be in your memory forever if I draw a picture. If I draw a picture, it will be in your memory forever. For example, suppose you have something like this. Okay. So in this case, suppose these are all elements that are of the same types. Okay. And suppose this is the mean. Okay. So in the K-mean clustering, so these are the, when you find the distance by using Euclidean distance, so all of these surrounding in here, so it is a cluster. So now take another color, suppose you want to consider here like this. So here is the, then you are finding the distance by Euclidean distance. So it is another cluster. Okay. And then finally, third one, if I want to write it in this format, you can get there like this. So in this case, it could be the mean, and then they are finding the distance Bayesian using Euclidean distance. And then you are saying that these companies are the same type of companies. They provide the same types of services. These are the another group of companies. They produce the same type of services. And this is the another type of company. They provide the same kind of services. Remember the clustering problem when we did it for a small data sets that has just 22 companies, and then we group them in 3 or 4 clusters by using k-means clustering as well as hierarchical clustering, and finally we constructed the dendrogram, right? So that is what called the classification. Now yes, that is what called the clustering. Sorry. Now we are going to discuss about the classifications. So in order to discuss the classification, suppose I want to find like this one, and then I want to take another color like this, and then I want to take another color like that. Okay. So now in these 3 boxes, in these 3 circular format, let us consider the smallest circular format. In this circular format, suppose there are this. There are suppose this. Let me put a totally different color. Let me put here purple color. Suppose we have a triangle in there, and then there is a circle. There is another triangle in there, and then there is a square. Take a look at that. And then there is again circle, 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 and then again triangle, and then triangle, again triangle, and then again circle, circle, something like this. So now it is mostly circles and triangle. In this circle and triangle, I also put a square, which is this. So now I want to predict, I want to classify whether this that square that we put, that should be a rectangle, or that should be that is what we want to predict. We put a square in the green circle area. On the green circle area there are 3 rectangle and 1 circle, and I want to predict whether my square is a rectangle, my square is a triangle or a circle. That is what. Now take a look at that. In the green circle, there are altogether three triangle, and one circle. In the green circle, right? So now probability of a triangle is what? 3/4, and probability of a circle is what? 1/4. So in these green circle area, if we want to predict what would be the form of a new image, that square, so we can come up with that as there are 75% is triangle and 1 is circle. So my fourth image, that means like my square would be a triangle. So we assume that this one on which we want to predict what type of shape it should be, like this one. Now we want to predict that sees most of the images in this circle are triangle. So my that square that we put, which I want to predict, we can predict that this should be the triangle. Why? Because originally in the green circle area, there are three triangles and one circle. A new observations, a new image, a new picture I put in that circle and want to predict whether it should be a circle or it should be a triangle. I want to predict that. Since most of the images on that green circle are triangle, so that means 75% of the pictures are triangle. So I assume that like my observation or my future observations or the images that I just put, that image should be the triangle, because most of the images on that green circle are triangle. Okay. Now take a look at that. Now suppose I want to predict that one. I want to predict that one in this black circle. In the black circle, I want to predict this one, like the one that I just put, this one. If I want to predict that one, now take a look at that. How many circle is in there? 1, 2, 3, 4, 5 circle. Okay. How many triangle there? 1, 2, 3, 4, 5, 6. So there are 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 6 circle. And how many triangle? 1, 2, 3, 4, 5, 6. So 6 triangles, right? So now 50% is 50% is circles, and 50% are triangles. 50% is circles and 50% are triangles. 50% are circle and 50% is triangle. So we can predict that as there is no majority vote. So it could be a circle or it could be a triangle. On the other hand, if I put a additional circle in there, so that means there will be 7 circles and 6 triangle. We can say that my new observations, which was a square, it could be a circle, because out of 13 images, there are 7 circles and 6 triangles. That's the way classification is done. So in order to do that, what formula they use in KNN? They compute from these, on which we want to predict, they compute the distance. They compute the distance like this way, K nearest neighborhood. After computing the distance, then they will decide. So among these distances, minimum and maximum within this range, we will get uh, like that was our distances we computed. So we will say that as in that range we have most of the images are uh, circle. So the square that we put, it should be a circle. That's the main idea. Okay. After going that idea, suppose now how to compute the distance of a data vector like x1, x2, and xn. This is one, and then another one is u1, u2, un. Okay, u1, u2, un. Now, how can I compute the distance? Euclidean distance could be computed by like this: x1 minus u1 square, x2 minus u2 square, and then it will go xn minus un square. That's the way it will go, distance. That's the way it will go. Okay, now let me go and open a document that I want to discuss now. Let me see. If it is not open, let me open it from there and read class note. So I recommend you highly. I recommend you highly at least to read my handwritten note that I have uploaded in the online portal. Okay, online portal. Or if you read this book, which is this, like I already uploaded this book in the online, and this is available in the online. This book, chapter 7 and chapter 8. Chapter 7 and chapter 8, which discusses in details what is KNN and what is naive Bayes classifier. What is KNN classifier? What is naive Bayes classifier? These two chapters, if you read and watch my video, then everything will be very easy for you to understand how these two classification methods is used for classification as well as prediction. Okay, KNN and naive Bayes. These are the two classification methods now I am going to discuss. And you have to understand the Python code, without which you would not be able, without understanding of the Python code, you would not be able to solve your homework problem. Okay. Now, let me read something from there, and then I will go for the code. After finishing this, then I will go for the Bayesian method. So KNN is used for classification and prediction purposes. To classify or predict a new record, the method relies on finding similar records in the training data. Similar records that I showed you, similar records, how many records are found that have the similar thing. So these neighbors are then used to derive a classification or predictions for a new record by voting. It could be either by voting or could be averaging. Okay, so that the idea of k nearest neighbor is that this method is used to identify k records in the training data sets. K records, we have a training data, we have a test data. In the training data, we have to identify k records in the training data set that are similar to a new record that you used to classify. I was given another record and you asked me to classify these things. For example, you have given me time, departure, airport, and then you gave me the name of the airlines company, time, departure, airport, name of the airlines company, and destinations, and you want me to identify whether this flight will delay or not. You have to classify that. So delay 0 and 1. 0 means no delay, 1 means delay. So that's the way you give me a piece of information, a set of information, and ask me to classify a new observations. Okay. So KNN algorithm is a classification method that does not make assumptions about the form of the relationship between the class members and the predictors. So like the way regression simple and multiple regressions, we have Y, which follow a linear trend, and then X1, X2, XP are the predictor. So we already assume that Y follow a linear model. But in this case, in classification, we do not assume anything about the parametric form of the response variable and the predictor. We do not assume anything. So this is a non-parametric method. That's the reason we called it as a non-parametric method, because there is no parametric form for the assumed relationship between predictor and response variable. To measure distance between records, popular Euclidean distance is used. For the two records, we have to compute record like this way. Okay. Now, let me show you a graph from the Python code. We want to see a graph from this Python code. Okay, so take a look at the plot. In this plot, new household is this. So what are the types of the data? Types of the data is you have a data that has a income. Each household has a income and how many square feet of the house. Okay, so now a new household we want to consider, and then we want to predict that household has certain characteristics or not. Take a look what type of data it looks like. So if I give you like this, IPython, and then if I want to write here after reading the data, this is called MAWA DF. So MAWA DF dot head. This is the data. In this data, I have a income, lot size, and ownership. So the income is 60,000. His home lot size is 18.2. Income is 87,000. His lot size is 23.6. So this is the income and lot size are our predictor, and ownership, whether the owner of a home own a landmower or not. That is what we want to predict. Okay, that is what we want to predict. Now, if you take a look at the graphs that we previously had, in this case, orange is owner and then blue is non-owner. So we have plotted these things in a scatter plot with the level of whether each scatter plot corresponding to each data point corresponding to the scatter plot of lot size and income has a level owner and non-owner. Now, new household that I want to predict whether that new household will be in the owner category or non-owner category. So we want to consider here this star, and then we see the shortest distance is from 4. So if we take one NN, one nearest neighbor, that means then in that case, star will be closest to the 4. And in that case, 4 is the owner, star will be the owner. Now, if we want to take a 4 nearest neighborhood, k equal to 4. So then what are the coming? If k equal to 4, if we consider, then 1 and then 9 and then 4 and 14. These 4 will be closest to the star. Okay, these 4 will be closest to the star. Now you see there are some of those are filled up and some of those are vacant. For example, orange circle are filled up, orange circle are not filled up. So this is filled up and non-filled up because of training and test data. Let me check again quickly. Whether what I'm saying is true or not. So it's page number 17. Yep. And then 10 Wilson said hollow marks. Yeah. So the solid one, uh, solid diamond and solid circle are the test, are the training. solid one are the training, and then hollow one are for the test. So or validations. Now from this figure we can take a vote and we can immediately say that if we take 1 NN, then the start, the new home that has a income of let me check in here. New home new household that has an income of 60,000 and lot size is 20,000, that one belongs to a owner category. So this is a home that is lot size is 20,000 and income is 60,000. If I take one nearest neighborhood, that means this distance is the smallest distance. So it falls in that category. So that means new home will be in the owner category. Again, if I take the 4 nearest neighborhoods, then the 4 members will be this one, 1, 9, 4, 14, because the distance is, in this case, if we take the voting, there are two are voting, two are voting for in favor of owning. So that means majority of the vote in favor of owning a uh, uh, lawn mower. Okay. Now I want to do so what I have done here, I take code for normalizing data by finding nearest neighbor. Like the way we discuss in clustering and classifications, if the variables are on the different scale, you have to uh, normalize the values for the predictor. Otherwise, the distance will be unstable. Distance will not be stable. So we are normalizing data in here. After normalization, now to compute the KNN. After doing that, we are doing the computation for the KNN. After doing computation for the KNN, so here Z income, Z lot size. So that means standardized, and then rest of the thing has been kept as it is. And we want to take a look only first 3 observations. So that is why I put 0, 0 to 2. So 0, 1, 2, that means 3 observations. These are the 3 observations. Okay. After that, code for measuring the accuracy of different K values for validation. So we have to do which K we should choose. Okay. Which K we should choose. That is the important thing. We should choose a K for which our accuracy is highest. For example, if I choose K equal to 4, that means 4 classifications, 4 observations, then our accuracy is 0.9. Now, if you have a question how this accuracy is being computed, then this accuracy will be computed by using, if you read the page number, if you read the page number 188, that clearly mentioned, because of they consider one K, different values of K, they compute the error rates for various values of K. For example, if we choose K equal to 1, we will classify in a way that is very sensitive to the local characteristics of the training data. On the other hand, if we choose a large value of K, such as K equal to 14, we would simply predict the most frequent class in the data set as all cases. There is a stable prediction, but completely ignore the informations in the predictions. To find the balance, we examine the accuracy that results from different choices of a key between 1 and 14. Okay, so if you read the last paragraph of the page 188, then you will see how they have computed the accuracy. Because they computed the accuracy, they considered the K value, and then after computing the K value, they computed accuracy for the changing values of K. Okay. So for our case, it is wise to use the K equal to 4, because when k equal to 4, 0.9 is the accuracy. Code for running the algorithm to classify the new household and retain full data sets. Now, if we run this, we see like new household uh, will fall in the owner category. Okay, new household fall in the owner category. This is what we have seen. So we have used here k equal to including like the new observations we consider here, including the new observations we consider here 4. So that is why there are 4 observations in here. Okay, so in our case, we are asked to use k equal to 4. That is what we have just seen from the from this output. Okay, now we will go to the base classifier. Okay, in order to do the base classifier, we need to understand how base classifier is different from the in order to understand what is naive base. Let me write it. So how does naive base is different from a base classifier. Okay, so in a state of deriving these things, let me show you the derivations from the handwritten output, because if I derive in here, your video will be too long. But I want you to understand why, how naive base is different from this one, how naive base classifier is different from that one. Because base classifier was existing, which was developed by a reverend, which is developed by the Reverend Thomas Base, 1702 to 1761. So that means this Bayes theorem is existing. So why we are unable to use this theorem? This theorem, why we are unable to use these things? And why you need a naive base? That is what need explanations. If you understand the explanations, then things will be way easier. Okay, let me first derive these things. So suppose A is an event, this whole thing is an A. This whole thing that you are seeing in here, this is just the A. This whole thing that you are saying, this is just A. Okay, and this is the event B1, B2, B3, BK, BK1. Sum of BIs will constitute like entire thing, entire B. Okay, now I want to find the event A. That means A. A could be written as A intersections B1. A intersection B1 means this in. A intersections B1 means this part. Okay, A intersection means that part. And then A intersection B2 means this one. Then A intersection BK means that one. So that means A could be written as an intersection of this one and that one. A could be written as intersection of B1 plus B1 intersection A plus B2 intersection A plus B3 intersection A, all the way up in there. Okay. Now probability of A could be written as probability of A intersections B1 plus probability of A intersection B2 plus probability of A intersections BK. So that is the way, because this is the disjoint case, as it is disjoint mutually exclusive case, this could be written like that way. Okay. Now, this joint probability can be written like this way. This is the formula. This is the formula for the joint probability. So let me write it. You know that one. Probability of A given B could be written as probability of A and B divided by probability of B. So these things equal to multiplication of that thing. So this is what we have written. These things equal to multiplication of that things, that thing. So this could be written. Okay. Now A could be written like that way. Now if I want to find now happening of B, now I want to find the probability happening of BK. I want to find the happening of BK. I want to find the happening of this one, this one, this one I want to find. How can I find that? We can find that by using Bayes theorem. After plugging this value, we will get this. So this is called Bayes theorem. Okay, what this is what called the Bayes theorem. But what is the problem of the Bayes theorem? Now I am going to show you in order to compute this value. Now, what is the problem of the Bayes theorem? I am going to show you. What is the problem of Bayes theorem? What is the problem of Bayes theorem? Bayes theorem that motivates statisticians that motivated statisticians to develop naive Bayes. So now I'm going to discuss about the problem. What is the problem? That is what. In order to discuss that, try to understand. Let me open the example that I have taken. Very beautiful short example. Now in the next 10 to 15 minutes, 20 minutes, you are going to learn what is the limitation. Suppose we have a just two variable. I want to write here x1 and x2 and y. These are the two variables. In reality, you have how many variables? In reality, you could have 50 variables, x1, x2, x3, and then x50, and then y. Okay. Now, let me show you in two variables, the problem, what is the problem, and for 50 variable, how big the problem will be. Now, if I write here 0, 0, 0, and then 0, 1, 1, 0, 1, 1, and then 0, 2, 1, 0, 2, 1, and then 0, 0, 1, and then 2, 2, 0, and then 1, 1, 0, and then 0, 2, 1, and then 2, 0, 0, and then 2, 1, 0, and then finally 1, 0, 0. So this is the data. Okay. This is the data. In this data, there is how many zeros? Y equal to 0. You are getting 6/10. And which is the prior probability? Y equal to 1, which is equal to 4/10. So how many zeros? There are 6 zeros. How many ones? There are 4 ones. So that is what we have in here. Now, according to the Bayes theorem, if I want to apply the Bayes theorem, see what is the picture. The Bayes theorem that I discussed, according to that, if I want to find this, I want to predict y equal to 1. Y equal to 1, I want to predict y equal to 1 based on x equal to 0, 2. Based on x equal to 0, 2, I want to predict. So according to the Bayes formula, it should look like this. X equal to 0, 2 given y equal to 1 times y equal to marginal probability equal to 1 divided by two probabilities, probability of x equal to 0, 2 given y equal to 1. This is nothing. Y equal to 1 times probability of y equal to 1 plus probability of x 0, 2 given y equal to 0 times probability of y equal to 0. New denominator is the same. Now, take a look at that. I want to find this probability, right? When y equal to 1, which is the prior probability is given, y equal to 1, y equal to 1, x equal to 0, 2. Y equal to 1, x equal to 0, 2. This is the one I found. Y equal to 1, x equal to 0, 2. Right? So, how many places has y equal to 1? 1, 2, 3, 4. 4 places there are y equal to 1, which is a prior, which is a given, y equal to 1. The probability 0. So we got here 1 over 4 and times that is equal to 4 over 6. This is what I got in the numerator, and denominator I got 1 over 4 times 4 over 6 plus. Now y equal to 0. Y equal to 0, how many cases? 6 cases. And how many of them has 0, 2? 0, 2. 0, let me see whether this is a 0, 2 or not. That is 1 actually. I'm sorry. I write it something wrong in there. Let me go there. Take this. This should be. And I also take out that one. Now I want to this. I want to go there. This should be 1. Okay. 0, 0, 2 equal to 1 equal to this. This is what we got a probability in there. 1 over 4. Because there are 4 cases where y value equal to 1. And then only 1 cases in which x equal to 0, 2. So that is why out of 4, only 1 cases this is. So, and you understand 4 over 6, which I already computed in here. Okay. Now, y equal to 0, how many cases? 6 cases. How many of them 0, 2? I have nothing. So that means none of these has. Are you saying why I got this equal to 0? Because there is no cases where there is an exact match of x equal to 0, 2 y equal to 0 times 6 over 10. This is, why did I put here 1 over 6? It should be 4 over 10. It should be 4 over 10. It should be 4 over 10. Okay. So now take a look at that. I did not get any match. Okay. I did not get any match. How difficult it would be for just 2 cases, I did not get any probability in there. How difficult would be if there would be 0, 0, 1, 2, 1, 0, 0, suppose 3. How difficult it would be to find a match corresponding to y value, y given value, suppose 1, 2, 3, it will be to find that. So in most cases, we end up with these 0 probabilities. More. In order to avoid these things, the joint conditional probability will be partitioned into marginal independency, marginal independence. So in that case, because I am not finding this scenario in here, so that is why the probability equal to 0. So this scenario will be worst, WORST. This scenario, computing this scenario will be worst when there will be a number of variable, 50, 60 variable. Finding probability will be extremely difficult, and most of the cases, the probability will be 0 because you are not finding a match that you want to predict. In order to overcome these difficulties of being unable to compute probability, they apply here Bayes. They apply here naive Bayes. What does naive Bayes do? Let me copy these things. Naive Bayes do these things. Let me write it quickly. Naive Bayes do these things. Let me write exactly what they did. They consider that part as the independent part. The things, this one, they write like this way. They write it. Let me write it in here. So that part, probability of x equal to 0, 2 given y equal to 1, they said that this should be written by conditional independence y equal to 1 times probability of x2 equal to 2 given y equal to 1. So these things, x1 equal to 0, y equal to 1, x2 equal to 2, y equal to 1. They said now the way joint probability, joint conditional probability that you are estimating, that you are finding from this, it will be extremely difficult because of 50 observations, and there are difficult to find a match in order to compute a probability. In that case, probability computations will be very hard and results will be unstable. So what they have done, this is the Bayes theorem, this is the Bayes theorem, and this is the Bayes theorem. This is the Bayes theorem. This is the Bayes theorem. On this Bayes theorem, this part, they make a conditional independent like this. These things can be written like that way. Entire thing has been changed. They name it as a naive Bayes. The computations of the probabilities will be easier. So now they, by using naive Bayes, they compute this probability. They want to classify the whether the like the owner of a mower equal to y equal to 1 means the person own a lawn mower, and 0, the person does not own a lawn mower. Okay, lawn mower. So they want to now compute this probability for y equal to 1 and y equal to 0 under these two conditions. Under these two conditions, they want to compute. If this probability is greater than that, then you said that, well, the new home with 20,000 square feet and 60,000 yearly income is a owner of a lawn mower. Okay, that's the thing. Now, another thing I want to mention, the Bayes naive Bayes classifier is used for categorical covariate. Categorical covariate, this would be used. However, if you have a continuous covariate, how can we handle these things? If you have a continuous covariate, you have to handle this. Suppose you have a blood pressure. Blood pressure, suppose you have 70 to 140 is the blood pressure, right? So in these 70 to 140 blood pressures values are coming. So you have to categorize them. So 70 to 90, there is a blood pressure category 1, and then 90 to 100, 90 to 100, there is a blood pressure category 2, and then similarly 130 to 140 equal to 110, 3, 24, this is 6. Okay, so now continuous variable are transferred to categorical covariate, and then after transforming these to the categorical covariate, you can do like computations of the posterior probability. Okay, by using naive Bayes theorem, we are classifying whether a new home, a person own a lawnmower or not. Based on the given data, you are predicting a new one, where under these predictor values, whether what is the probability of owning a lawnmower, under these predicted values of access, what is the probability of not owning a lawnmower. And then if the probability is greater than certain cutoff value, you can say that own and does not own. Okay. What else I can discuss? Uh, I said naive Bayes are for the categorical covariate. If there is a continuous covariate, you have to recode the continuous covariate to the categorical covariate, and then you can find the probability. So I think that's it. And now let me run the Python code. Python code. So in the Python code, we want to, we on the basis of some uh, predictor variable, categorical covariate, we want to predict whether the flight will be delayed or flight will arrive on time. This is the things we are going to do. These are the classification we want to do. We want to do whether it will be arrived in time or whether it will be late, it will be delayed. So let me first run this data and take a look at the data delay underscore df. This is the data, and the data has how many? np dot shape. It has 201 rows and 13 columns. Data has, if you want to view and then click on there, this is the data. This is the data. Okay. So take a look at that. Some of these are okay, all of these are categoric. So this could be transferred to the categorical variable. This is the fly date, and this is the departure time. This is the arrival. Where is the arrival time? Day of the week, month, and then flight tail number. All of these things is given in the data. I want to convert it to the categorical. Now, I'm teaching a class. So that is a create hourly beans departure time. So departure time was given in a continuous format. As I mentioned, if there is a continuous covariate, you have to transfer it to the categorical covariate. After that, I am finding this is my predictor, and that is my flight status. So that means on time and delay. I'm converting that in a beautiful data frame format. If I want to take a look at the data, so I choose 1, 2, 3, 4, 5 covariates, which are days of the week, whether this is the first day, second day, third day, fourth, fifth day, sixth day, seventh day, CRC, departure time, origin, and destination, and carrier. These are the covariate I have now. If I take a look at this, so these are the covariate, and then this is the dependent variable on time and delay. So we want to put them in the classes. Have been made as a classes. Split the data, training data and test data for both covariate as well as for the response variable on which you want to make a prediction. Uh, Just give a second so that my pip install DMBA got installed. Okay, it's fine now. Let's see. Hopefully it will run okay. Yeah, it is running okay now. Now I'm doing the predictions in there. I'm creating the pivot tables. And finally, I want to take a look at in this case, carrier and flight status delay and on time. And this is the carrier. So that means Delta. And then these are the name of the um, airlines carrier. And after that, I want to classify a specific flight by searching in the dataset for a flight with the same predictor value on page 209. In that case, I want to find a specific with a specific set of covariate, like the way I theoretically derive specific set of covariate I want to find on this, and then actual and predicted value on time. So 0 and 1. So it is a 94% probability that it will be an on time, and predicted 0 and 1. 0, that means not on time, is probability is this. I want to show you the class confusion matrix. Okay. Okay. So here is the thing. Confusion matrix is created in here. It has for the two types of data. One is called the training and one is called the validations. For both of these, we got our accuracy 80%, and which is a very good accuracy. And then we got on time for delayed, mm, delayed, but on time. And this is the correct classifications. So we are predicting 26 and got the things, but this is a misclassification. It is written here on time, but actually it is actually delayed. On the other hand, this is also a misclassification. It is said delayed, but it was on time. And this is a correct classification: on time, delayed, delay. So this is the result for both validation data as well as training data. And this is what we are getting. The graph saying as like the number of records is increasing, so cumulative gains, like the more stable cumulative gain means correct classifications, that rate is increasing. Okay, I'm going to stop in here. I will upload this video. So again, please, from the textbook, read chapter number 7 and 8 thoroughly, and then Python code, try to understand and do the homeworks. It's the easy homeworks. What I have done, I have given you the code. You have to just change the data name and variable name, and output is the same. Okay. And I recommend each of you, in order to become a master in analytics, please finish this book from cover to cover, from front page to back page, cover to cover. Finish this book, then you will learn a lot. Thank you very much. I will upload for next video for the logistic regressions and profit model.